Hi, Simon here today. I'd like to talk to you about 1.5 degrees and the global average surface temperature. What's that about? So 1.5 degrees, we hear about that all the time. That's obviously the temperature rise. We're trying to limit the planet's temperature rise too. But 1.5 degrees sounds on the face of it fairly benign. I mean, on a nice summer's day, 1.5 degrees, not a big difference. On a winter's day, it might seem rather welcome. So, what is it actually about? And it's not, it's actually, unsurprisingly, much more than that. So, let me jump into the presentation and try and uh, give you some more information. So, if we just jump in there, here we are here. 1.5 degrees and the global average surface temperature. So we see lots of graphs like this. Here is the rise in temperature over time, and we can see that very recently, 2023, overlaid here on historic temperature variations over the year. It's terrible. It's getting much worse. But it's also, when I look at this graph, I see it's with reference to a baseline. And so it raised two questions for me when I first, well, not when I first saw this, but more recently. Why do we present temperature anomalies as a difference rather than an absolute? Why do we talk about 1.5 degrees rather than the temperature will go up to such and such? And the baseline, how is that derived and what does it all mean? So, to try and find out, I first of all went back to the Holy Grail, of course, the IPCC reference reports, which on everybody's everyday reading list, of course. But if you wade deep and deep into it, not too deep actually, but lots of verbiage, as those reports are. If anyone's ever looked at those, you'll know what I'm talking about. But anyway, the global average surface temperature is a construct. It's not a measurement. There's not a single thing really called a global average surface temperature. It's a weighted average. There's many data sets which are used, some of which look at air temperatures, that's called the SAT. Some are surface sea temperatures, SST. And of course, because there's many data sets, these vary. Obviously, there will be differences between the data sets in terms of where they take their data from, what period they use, how they treat historic volcanic activity, how they treat seasonality. And so that's the variation within the historic data sets. And then going forward, though, there's modeling, which tends to use just a single figure. So to try and it seems to be that to try and get consistency across all these various data sets. And here's just a sample of them from, again, the IPCC report. And these are just a sample. There's pages of these things, covering different time periods, and they're averaged, and they present ranges and confidence intervals. So there's just a huge amount of data in there, and it seems to me that in order to try and get consistency, so this is a reference point so that people can the scientific community can coalesce around a single way of expressing things. It was agreed to sort of present these as a difference because the difference is what matters really. It's as an analogy I like to think of. If you don't really care too much whether you are traveling in a car at 20 or 22 kilometers an hour. If you're hitting a tree at 40 kilometers an hour faster, it's the 40 kilometers that matters. Don't talk to me about the, yes, I know, kinetic energy and all that sort of stuff. But the point is, it's about the impact, and the impact it comes from the rise in temperature. So this seems to be why it's done as um, a difference. So that's interesting, I thought. But then you say, well, okay, that's fine. But why it's only 1 degree? So what? But 1 degree is significant because we're talking about a change in, as you see, it's the average surface temperature of the air and the sea. And that's a huge amount of energy to do that. As it says here, 1 degree temperature in the surface temperature means you're warming the whole planet by a huge amount of energy. Enough, as it says here, for 4 million years of energy consumption in the United States. It's a huge amount. So 1 degree is a big deal, and 1.5 is a bigger deal. So that sort of was interesting. But then I thought, well, what is it? Again, coming back to that baseline, 1.1 or 1.5 degrees compared to what? There's actually less data out there about that because all the focus is on the differences, But I have found a couple of I think, reliable and useful things to say what was the global temperature like in the baseline. And here we have one from the American Institute of Physics, and I found very similar numbers in NASA and the National NOAA, other reputable websites, all roughly around the same. The baseline was about 13.6 degrees C. Currently, our mean global temperature about 14.8 degrees C. And that might seem colder than you expect, but again, it's because it's the averaging the sea temperature and not just, and it's that which brings it down. So compared to our baseline, that's about a 9% increase. So on that measure, a 10% temperature rise, that sounds a lot. On a 2-degree increase would be 15%. Wow. So there's two takeaways for me from this. One is that the context of something is important, as always. And the second for me is that a scientific consensus might not be the best thing for a call to action, or for me at least. A 10% rise in temperature. That sounds to me like a much more compelling call to action than 1.5 degrees. But I don't know. That's just me. If you think something differently, or if you agree with me, please put something in the comments. And yeah, please subscribe if you enjoy this. Thank you.